So all over particular factories, you will see these types of panels, a red button and a few other buttons and lights and LEDs around. These electrical panel covers are very common, and they're made for all kinds of electrical enclosures and machinery. But they're actually fairly expensive to produce, because even though in industrial machinery you're going to make a fairly low quantity of units, you generally have some sort of tooling or machining cost in order to make these panels. 3D printing can really help to solve this issue because you no longer have the cost of tooling. That's much more affordable than machining to produce these types of plastic pieces. But you do have to make sure that you're designing for the process to create a good quality product and create it affordably. So in this video, we're going to go through those design steps of creating an electrical panel cover. So let's start with the very basics. When designing a panel cover like this, number one, you really want to lean into the fact that you are not restricted to a particular thickness of material. You can make it as fat and chunky as you want because you can have all of that rigidity and we will fill it in with infill. But in this case, we made a panel cover that was 2 to 3 millimeters thick throughout, just because that's very often what comes back towards us from existing designs. So we're going to try to pull from that. What you want to do is you want to make sure that the entire panel is chamfered all the way around the outer edges as much as possible. We want 45-degree angles. You don't want to do rounding or beveling because that actually creates problems with manufacturing where you can end up with ripples on the bottom of the part where those areas actually create a sag. So if you do have to fillet some part of the part, you want to make sure that it's as small as possible. So we did fillet the outer corners of this part a little bit just to round off the edges so that they can align with whatever box this might be mounting onto. Now the holes themselves, of course, you want to fillet just as much as possible too, because you don't want any kind of drag or any kind of hitch happening in these areas. You can make slots for LEDs, you can make slots for the individual buttons that you might be putting in, whatever kind of display options you need in this you can do. As far as mounting up of these devices, if you're doing like an LCD screen that needs to have multiple screws around the outer edges to mount it up, I recommend looking at one of our other videos where we talk about screw holes and sprues in order to view that. Now, once that whole panel is done, you also have the text. The text itself you can separate from the rest of the panel. Very often when people 3D print them, they produce parts like this, where there's not very much contrast with the text. What we have done is we have actually applied a texture to this panel, which is applied digitally so that it is actually printed with this texture on it, which gives it a very nice pinned look that is not very common and is way better than like the virgin 3D printed look for this kind of stuff. But while the main surface has that texture, the text itself is totally smooth, which gives it a nice bit of pop and contrast compared to the rest of the part. This text is raised up anywhere from 0.5 to 0.75 millimeters, and that ensures that it's separated far enough away to really be distinct. You don't want to go up to a millimeter, otherwise text can start to sag and deform, and you don't want to go smaller than that, otherwise you can't really get it contrasted from the rest of the part. Now, those are all the basics. You want to chamfer everything as much as possible, design around the texture, that way you have this really nice surface finish, and do some basic stuff with text, and that gets you a panel. But here is the thing. Most of the time when people go to attempt to print these sorts of items, they print them flat, horizontal like this, and they have them facing upwards. This number one is a terrible idea because the text itself is individual islands, individual areas that the tool head has to operate on, which means you're now limited to tool head diameter. You can't have very small text. You always want text on the side of a part because it can be very crisp. So you don't want to print it like that because there is text up here. The other side of it is you want the surface finishes to be uniform, and up here on top you cannot apply a texture to it. That will just be the printer printing straight across. So you have that rastering look, and again it can lead to a lot of errors in production. The other issue is with a large flat part like this is that it is very well adhered to the print bed. So it has almost no scalability at all because each time a part is done, it has to be removed from the bed by hand or through some other fairly intensive process to separate it from the bed. We generally try to pursue auto ejection, which is a part being removed through automated methods from the printer once it is done printing. And we can't do that when it is large and flat and broad like this. So what is the solution? Well, you put it up on end. Now, people do not want to put it up on end very often because it seems unstable. And that is true if you are prototyping with like a bed slinger machine or something like that. But this is not an issue for our machines because they don't disturb this. That being said, you never want a tall part because as it grows, it can cause little amounts of warp. And you can actually see that appear on some of the prototypes that we've done. Here's one where you can see some of that kind of Z banding, which is from the part warping and bending as it goes up. So in order to reinforce this part, you actually apply some feet to the bottom. This makes sure that it can't fall off and that it doesn't warp or deform. These designed supports are better than standard support because number one, this does not exist. These are basically fins that stick out the outer side. They interface with the panel in the back on the inner seam so that when we work and break them off, they break away cleanly and you can't even tell that they were ever there. But they provide a tremendous amount of support to this part as it's growing up. Technically, you only really need one of these in the back of the part because that will give you a triangle of stability as far as the footprint that the part is sitting down on. But a couple of them is always good just for redundancy, and these don't really add any material and they are a trivial amount of post-processing. But then you end up with a very crisp, nice looking electrical panel cover that looks as professional as anything else that could be produced. And you get your text printed on there without having to do any sort of post-processing like adding stickers, and the part itself just looks very crisp and clean, and you did not have the cost of tooling to produce it or the long lead times of machining and the cost associated with that. Printing is a much more scalable process, and you can get nice final products for your electrical component covers very quickly, very easily, very reliably, and at a very high standard of quality. Comment down below if you like that video. Let us know other sorts of components that you'd like us to go over about how to design them for mass production printing. These types of pieces are very often kind of slightly misunderstood about how to really optimize for the process, so we always like going over these. And do subscribe to the channel. We do these videos on a semi-daily basis, so we're always producing new content about how to design for mass production printing so that you can produce your products at scale without having the upfront cost of tooling or any of the other struggles with warehousing and shipping that can come with traditional supply chains. Have a great day, everybody.